Hello students, how are you all? Hope you are all fine. Okay, so we have already started chapter 7. I explained you the very first part, chapter 7 of sum, right? And also in the last class, I discussed the numericals with you, right? Students, now that your test is postponed to Tuesday, again I repeat the same. Very important, just prepare all the numericals. Okay, very simple, basic, direct formula based numericals are there in refraction of light at plane surface, chapter 4, right? Okay, all the formulas. Then at the same time, few exercises we did in the school itself of chapter 4. Okay, so the register work which we have written in from the form of factors, depending, definitions, important short notes that I gave you, ray diagrams, do it very carefully. Okay, you all must take it very seriously, students, and I want excellent results in the same, right? Practice all the ray diagrams, the conditions, the factors, okay, the definitions, properly everything, the ray diagrams, numericals, everything. Okay, basic concepts all must be very clear. And this exercises which we have done in the online classes, go through all the content. If you have not done a few things whichever are left, you've got one more day, let me tell you. Okay, so as far as today's class is concerned, I'm just explaining you the concepts. I'm not taking, students, very clearly, I'm not giving you any written work. Okay, because now that the test is on Tuesday, I'm not giving you any written work, but then the understanding part, for that I'm explaining, you all must understand the same. Okay, so quickly I'll start with today's class. Fine. Okay, yes, so this is chapter sum part 2, where I'm going to, in the first part we had a discussion about sound. What is sound? A sound is a form of energy, right? It produces sensation of hearing into our ears. At the same time, we said that any body, if it vibrates, it produces sound. It can be the membrane of the dholak, drum, or we can say the strings of the guitar, sitar, all these instruments. Okay, anything, the rubber band, when we pluck it and release it, anything that vibrates produces sound, right? I also took the live example of our vocal cord. When we keep our hand on our neck and we speak something, we can feel some kind of sensation, right? So all that we discussed. Then we also discussed the range of audibility. Fine. Echo, very important part of the 7 exercise. Reflection of sound, basically it means. Okay, and various importance or the uses of the echo in our daily lives, right? Medical use also we discussed. Then also we discussed by the fishermen, dolphins, bats, right, by the submarines. So all that was explained in the last class. Second part of this chapter actually talks about, since we said that sound is produced when a body vibrates, right, students? So this vibration is not only of one type, it can be in many ways, right? For example, if there is a body which is made to vibrate and it keeps vibrating with the same amplitude, then it is different. And the one which is vibrating with the amplitude firstly maximum, then decreases ultimately, so all these are different. So in the second part, again it is the important part of chapter sound, we are going to talk about different types of vibrations which actually produce sound. We will start with the very first one, so pay attention what it is. It is the free or natural vibrations. Students, pay attention at the word. When I say free or natural vibration, it means the vibration which will take place in the absence of any resistive force, or I can say specifically that the vibrations which take place in vacuum, because in vacuum whatever vibration will be set once into a body, it will continue forever. So that's what it is. Okay, we'll talk about one by one. Next is the damped vibration, naturally which take place in our daily life. We see whether I talk about a pendulum or I talk about something else, so that's what it is. Any vibration which take place in the presence of air or any resistive force, right? Last is the force vibration, and its special case is resonance. Okay, so let's start with the very first. First is free or natural vibrations. The periodic vibrations of a body of constant amplitude. Students, if I am not wrong, in the last class also the terms related to a wave we discussed all. Amplitude, frequency, time period, all that I have explained you. So what is the word amplitude? Yes, what does it mean to you? Yes, it is the maximum displacement from the mean position. This is the mean position, the horizontal axis, the horizontal line. From the mean position, the maximum displacement, that is called the amplitude, right? So the periodic vibrations of a body of constant amplitude, that means the amplitude is not going to decrease. If it is set once with a height of say 10 centimeter, it will remain the same. That means that is constant amplitude. Okay. In the absence of any external force, okay, here external force is any kind of resistive force basically, or I can say the vibration simply that take place in vacuum, because this is also an important question. Directly the examiner asks you one more question: what's the condition for natural or free vibrations to take place? Students, in the one word answer is in vacuum, the vibration which take place in vacuum. Let's talk about more the same. The free vibrations are simple harmonic vibrations under restoring force, the amplitude and frequency of which remain constant. So amplitude as well as the frequency. Frequency, you all understand, number of vibrations made by the number of vibrations made by a particle in 1 second. So that's what it is. Once the body starts vibrating, it continues its vibration with the same amplitude and same frequency forever. Student, what we actually see in our real classes is mostly every year students ask this thing. Yes, they ask them what is it that forever means. See students, it simply means whatever we are saying, exactly the same. It means if there is a pendulum, you apply force on it, you made it vibrate, and it takes place in vacuum. It simply would mean that it will continue to vibrate with the same amplitude forever. It won't stop ever, and it will also vibrate with the same amplitude. Fine, is that clear? So that's what it is. This was all about the free or natural vibrations. So if I say a tree is made to vibrate in vacuum, that is also possible. A branch of a tree made to vibrate, you pluck, you hold it, apply force on it, and then release it. It will start vibrating. And if it takes place in vacuum vibrator, then it is free vibration. Pendulum vibrating in vacuum, simple pendulum. Okay, the sitar or guitar, the strings of that made to vibrate in vacuum. All these are examples of free or natural vibrations. Part is clear? Examples of free vibration, there are n number of vibration examples in your book given. For all those, if I give the condition as in vacuum, then it becomes the example of natural vibrations. Okay, so that's what it is. Okay, so here we need to understand this particular important part. All these examples, when they take place in vacuum, then that is for natural or free vibration. Okay, so next is damped vibration. This is the practical one, because practically vacuum is not possible. We just assume it as the ideal case, right? So damped vibrations are the vibration which actually we see in our daily life. Any body which vibrates with a kind of vibration called as damped vibration. What happens here is this, students. See the graph here. Displacement time graph here. Amplitude is constant, the body remains vibrating forever. And if I talk about this damped vibration, the body vibrates like this. Firstly, with maximum amplitude, it decreases slowly, gradually, and ultimately the vibrations cease, they stop, right? So that's what it is. Okay, so graphically this is how we understand. Fine, that the amplitude decreases and ultimately ceases, it stops. So let's define now the periodic vibrations of our body of decreasing amplitude. The amplitude is continuously decreasing in the presence of resistive force. Here the condition is that in the presence of any kind of resistive force. It can be air also, because air acts as a friction. Air acts as a resistive force. The amplitude of motion decreases, clear due to friction, we can say, or due to the resistive force of the surrounding medium, that is the air particles. The frictional force at any instant is proportional to the velocity of vibrating body, and it has tendency to resist the motion. That we all know by law of inertia. Fine, that's what it is. And the last is, as a result, the body vibrates continuously, loses its energy. Why this amplitude is decreasing, students? Because here the energy is lost in the environment. Whereas in the case of free or natural vibration, since they were taking place in vacuum, there was no medium, so no loss of energy was there. So here the energy gradually is lost for doing work against the force of friction, and the amplitude hence decreases. Clear? Now what will be the examples? Exactly same as that of free or natural vibrations, only with the difference that here it will be in the presence of resistive force and there it will be in the presence of vacuum. Vacuum is must there. Fine. Okay. Now this is the difference between, I'll be sharing this PPT too. Okay, but not for Monday. The reason is you have your test on Tuesday, so I just want you to understand seeing the video only. Prepare well for your test, Tuesday test, and then I'll be sharing the PPT of the whole chapter. Don't worry. So all these notes you can complete later once I share it with you. Till then, just the explanation part I want you all to understand. Okay, fine. So this you need to write it, free and damped vibration. 2 points of difference, students. 4 I am sharing with you, but 2 you need to write from your book and learn also. Next is, these are the examples of forced vibration. Okay, a tuning fork, it vibrates, it produces sound and then it stops. Okay, fine. Bell, the gong hits the metal, this thing, and then it vibrates and then it stops. So that's what it is happening. Okay, so the vibrations of a body, the strings of this thing, see here, strings, you pluck them, you release them, they start vibrating and they produce sound and they stop after some time. So that's what it is, force vibration example. The vibrations of a body which take place under the influence of an external periodic force acting on it is called force vibration. So this is the next one. Very, very important, student, this particular part. The vibrations of a body which take place under the influence of an external periodic force, that is called as forced vibration. So here what is needed is externally applied periodic force. Whenever it is there, the body will vibrate and the vibrations are termed as forced vibrations. Okay. Basically, I can take one example, good example of the same. Okay. Say you all know that the tuning fork vibrates. We will do the demonstration or all once we are back to the class. Okay. So for now, I will just understand it. There is a tuning fork. If I hit it on a rubber band, what happens? It starts vibrating, right? In class 9, this was explained to you by your teacher. So it starts vibrating, the tuning fork. Okay. Now once it's vibrating, the moment you hit it on rubber band, it starts vibrating. Bring it close to the, or touch it with the tabletop. Okay. What will happen is, if you keep your ear on the tabletop, you will be able to hear a louder sound, student. That is the case of forced vibration. I repeat, the forced vibration are having such kind of examples. One body is vibrating, due to that the other starts vibrating. So what is happening here? The tuning fork was vibrating, right? Tuning fork was vibrating, and the tuning fork, when brought in contact with the tabletop, that tabletop particles, there was motion, or molecules also, they also start vibrating, the tabletop molecules. So that kind of vibration is forced vibration, because here externally applied periodic forces act. Clear? Go through all the examples of the same, read line to line from the book, then it will be much more clear to you, students. Still I am sharing some slides with you so that it's that easily you are able to understand. Okay. Now the next comes the resonance. See, resonance is what? It is a special case of forced vibration. Okay. What happens here is that the frequency of the applied force, externally applied periodic force, if it matches with the natural frequency of the body, then in that case, the body vibrates with a large amplitude, produces a loud sound, and this is termed as resonance, and these vibrations are called as resonant vibrations. It is not a new type of vibration, it is a special case of forced vibration. But what is needed? Say there is a body with natural frequency of 256 Hertz. Okay, the forced vibration which are externally acting, that is also having a frequency of 256 Hertz. That means the two frequencies are now matching. Once the two frequencies match, this is no more a forced vibration, it is known as resonance. Clear? That part is clear. So that is resonance. What we want is, here the important condition is that the body must have the two frequencies equal. So be very clear, it cannot be approximately equal, nearby, nothing sort of that. No, exactly equal is the word. Okay. So what is it needed? Pay attention. This is the second part we are talking about. Resonance occurs only when the frequency of applied force, the externally applied periodic force, because the example that I have taken was of tuning fork, so the externally applied periodic force was on that. So that frequency, if it matches with the frequency of the tabletop which I am talking about, natural frequency of it. Everybody, remember students, everybody in the universe, every object vibrates with its natural frequency. Okay, it has its natural frequency value. So when these two frequencies will match, we will say that resonance has taken place. And how are you able to conclude that? It is just by seeing two things. One, large amplitude, and second, loud sound is heard. Okay, clear students? See this part now, slide. There are various examples given in your book, right? So these are one of those. One is, there are two tuning forks. The first one is hit on the rubber pad. It starts vibrating. Now there are two hollow boxes kept such that they are facing each other. So what will happen? The particles, the air molecules which are there in between, this vibrations will be passed on to the next particles. Due to that, this vibration will be sent to the second tuning fork also, and this tuning fork also starts vibrating. So here it's no more the case of forced vibration. What is the case? It is the case of resonance. Why? Because here this tuning fork will vibrate with a larger amplitude and loudest sound. See, this is the example more clearly explained you here. Resonating tuning forks. Due to the vibration produced in the first tuning fork, the second one also starts vibrating. Fine. So this is what an activity is. One more example is of the one which is given in your book, when we are having n number of metallic bobs or the pendulums, okay, with different lengths. We have it, the thread we are using, they are all clinged with the same rubber band. Okay, now what happens is, one of the pendulum is set into vibrations, and what we observe is the others also, one with a shorter length, one with a greater length, one with equal length to the given one, they all starts vibrating. So that is the case of natural frequency, that is a case of force vibration, okay, and resonance. Fine. So this example is also very, very important. Fine, student. Go through all the examples as I said, then only the reasoning part will be clear. Real life examples of resonance, we have many. Bridge. When the troops, they walk, marching when they do. What happens? They are all in phase with each other. March jab aap karte hain class student. What happens? We all march with the same phase, left, right, like that they move. So when they are walking on this bridge, suspension bridge, this is called suspension bridge. When they are walking on such a kind of bridge, what are they suggested to do is, they are suggested to not move in phase. What will happen if that is the case? Student, there are chances of that the natural frequency with which this suspension bridge can vibrate, if it matches with the frequency of the marching of the soldiers, then in that case resonance will take place, due to which this bridge will vibrate with a larger amplitude, and there are chances of this bridge may collapse. There are chances that the bridge may collapse. So that is very, very important. So that's why these soldiers, when they are marching on the suspension bridge, they are suggested to not to march in phase with each other. Okay, so that's an important case. Fine. Then the frequency, radio frequency, you must have heard it. Okay, when you set it in your cars, or I can say in your radios, when you tune into that. See, if I say a particular channel will catch at 92.7 big FM, like that. So example is there. So if that is the case, then it is not that particular channel can be heard nearby also. 92.6, you will not be able to hear that clear voice. You will not be able to hear more than that, 97.8 also. When you are able to hear it, when the two frequencies match, the frequency from where the service station, the frequency of the particular channel is sent, and then the other one which is sent from as a signals from the radio set is there. So when the two frequencies will match, radio waves and this, then only the resonance will take place. That means then only the clear voice will come in the radio stations. Okay, so the two frequencies need to match. Clear? There are many examples given in your book. Same goes with the TV signals also. Okay, so that is what it is, class. These are all live examples, very, very important. All the examples must be learnt and prepared very well by you all. Okay, then last slide we are discussing the force vibration and resonance vibration discussion, the difference between. Okay, Here the amplitude is large for resonant vibration. It is actually a special case of force vibration. Okay. Whereas here the amplitude is usually small. The vibrations are not in phase with the external force. Here it is in phase. That means they are equal. That is the condition. Very, very important needed. Fine. So you need to learn two difference between of. Okay. First is free and damped vibration, then force and resonant vibration. Two difference between each you need to learn, students. Okay. And in your register also the same. But for Tuesday, for Monday, no work for the same. Just understanding part. Okay. Now we're going to start with the next exercise in the next class. Meanwhile, you have to just revise and recapitulate all the points that we have discussed in today's class. Okay. So I'll just be giving you, sharing with you the exercise 7B question answers in the next class. Till then, just understand this part. Prepare very well for the test, students. All the best. Thank you.